So another thing that we can do, these are all non-acute larger than 90 degrees, right? And this is kind of an extension of what we did on the last section. To find cosine of this, that's a really big number. But we can plug it into fancy graphing calculators, and I can pass those out. But for now, just watch what I do here. If I say cosine of 1800 degrees, here, let me do it this way so you guys can see a little better. Oh, maybe not. If I say cosine of 1800 degrees and I hit enter, it's just 1, right? So where does that come from? All right. So what we're doing, and I want you guys to think about this. Remember, 1800 degrees will have a reference angle, right? So if I start here at 0 and I go around, that's 360 degrees. I go around again, that's 720. So we're going to keep going and going and going and going until we get to 1800 degrees, right? In other words, this is 0 degrees. This is 90 degrees. This is 180 degrees. This is 270 degrees. And after one revolution, it's 360. Okay? So I'm going to go till I get to 1800. Well, the first thing that we need to do is we need to figure out where that stops. So the first part that we would do is see how many whole revolutions I could do. And I think 360 divides evenly into 1800, but let's see. So I'm going to say 1800 divided by 360. 5 whole times. Okay? So because that equals 5, what we're really saying is we're going to make 5 revolutions around. In other words, this is 360 degrees. This is 720. I don't know what the next number is, but if we go around 5 whole times, we stop right here. So what does that mean? Well, remember, if we think of the unit circle, if we think of the unit circle has a radius of 1, so that would stop right there. And in terms of a unit circle, the unit circle is like that, sort of. Let me fix this. Where it has a radius of 1, right? Now, also, we know from our unit circle, and you guys could go back in your notes and look at the unit circle, that the x comma y is going to help us determine the trig values, right? So what's the x value right here? Positive 1. What's the y value? 0. What is the radius? Well, we said on the unit circle, the radius is always equal to 1. So how does that help us? Well, for part A, cosine of any angle theta is equal to x over r, which is just going to be 1 over 1, which equals 1. That's what our calculator said, right? Now to do secant is the reciprocal of cosine, yes? So that would be r over x, and that would be 1 over 1, which is 1. So for this one, we've got 1 plus 1, which equals 2. Okay? And you're like, what? No, that's what it is. Now, unfortunately, we don't have a cosecant button on our calculator, but we know that it's I keep saying cosecant, it's secant is what we're doing. We don't have a secant button on our calculator, but if I say cosine of 1800 degrees, oops, not 18,000, although it'd probably be the same, plus 1 over cosine, whoops, 1 over cosine of 1800 degrees, right? Because that's how we have to plug it into our calculator. It's the reciprocal. Dude, nothing up my sleeve. Okay, so let's copy and paste that in there so you guys can see how to enter that in your calculators. And now that we've done all the legwork, we could do a very similar thing for B, although we have to recalculate everything, right? So for B, we've got negative 270, negative 270. So I'm just going to sketch this out. For B, we're going to have our XY plane. Where this is X, this is Y. This is 0. Now, because it's negative, remember negative, we rotate this way. So this is negative 90. This is negative 180. And this up here is negative 270. In other words, our angle is going to go from here, oops, this is our terminal side, right? Not terminal side, that's our initial side. And from there, we're going to come around negative 90, negative 180, negative 270. So we're going to put, this is our angle. So now to do the calculations, our point is right here. So what is that XY value? Well, the X value is 0 and my Y value is 1. Right? So X equals 0, Y equals 1. And my R value on the unit circle is always going to be 1. So we're going to do kind of the same thing. Let me, I'm running out of room here. But cosecant is the reciprocal of sine. So cosecant of theta would equal the opposite over hypotenuse, or the hypotenuse over the opposite, which would actually be R over Y, right? Am I getting that right? Plus cotangent, which would be cotangent of theta, would be the X over the Y. So cosecant of 270 will be R, which is 1, over Y, which is 1. So this whole thing equals 1, right? And then, in other words, this would be, I'm running out of space here because I didn't. This would be 1 over 1. And this one over here is X over Y, but X is 0 and Y is 1. So this would be 1 plus 0, which would be 1. Now we can still plug this in the calculator, but we don't have a cosecant or cotangent button, so we have to do the reciprocals. So cosecant would be 1 divided by sine of negative 270 degrees plus 1 divided by tangent of negative 270 degrees. And we're going to get an error because tangent is undefined. Probably in this situation, yeah. Tangent would be undefined. So we can't even do that on our calculator. So that's why we got to kind of know the math. Yes, question?
Can you explain why it's 0, 1 again?
Sure. So cotangent is the reciprocal of tangent. So let's think about what tangent is. Tangent is the opposite over the adjacent. But in terms of the xy plane, that's y over x. Right? So if I draw, I'm running out of space here. Let me explain this on another slide because that's a good question. So if I think in terms of, oh, that's a horrible, let me just get an image here. So if I draw a right triangle, so hard I don't have a ruler here, like this. The question was, why? Where is all this stuff coming from? There's a point that lives right here on the xy plane. We call that x comma y, right? And also, we'll come back to that x comma y thing. So what we're really focusing on is there's an angle here called theta, right? This is 0 degrees. This is some measure of angle sweeping around. Well, this is in terms of a right triangle, this is the opposite side, yes? And this is the adjacent side. And the one across from the 90-degree angle is the hypotenuse. But it lives in the xy plane. So when we think about how we get from the origin to here, we go over, in other words, this point right here that I have graphed is actually 4, 3. Right? That means from the origin, I went 1, 2, 3, 4. And then I went up 1, 2, 3. Well, my opposite side length is 1, 2, 3, which is actually the y value. And then the length from here to here, my adjacent length is 1, 2, 3, 4, which is actually my x value. And then to find the hypotenuse, if we were to do the Pythagorean theorem, a squared plus b squared equals c squared, that's how we'd find the hypotenuse. But I could also do it in terms of x squared plus y squared equals the radius squared, right? Because this is like the radius, because we're imagining this this circle that kind of goes through this point here. We're imagining that there's a circle, that a circle exists. Oops. I highlighted the wrong thing here. We're imagining that this is a circle and this is the radius. That's why we use that term r, right? But we could also think in terms of opposite squared plus adjacent squared equals the hypotenuse squared. Well, then if I crank through the math, I'm going to get 4 squared plus 3 squared equals r squared. And you guys probably know this already. This is going to be 16 plus 9 equals r squared. So it's going to be 25 equals r squared. When you take the square root of both sides, you get 5 equals r. So those are the numbers, and that's the relationship between them. Where it comes from is that sine, if we think in terms of SOHCAHTOA, sine of theta is equal to the opposite over the hypotenuse, which is actually the y value over the radius. Cosine of theta is actually equal to the adjacent over the hypotenuse, which in terms of the xy plane is x over r. Tangent of theta in terms of is really the opposite over the adjacent, but in terms of the xy plane, that's y over x. cosecant is the reciprocal of sine, so whatever sine is, we just flip it. So this would be the opposite, right? So over here, it's the opposite over the hypotenuse, so we flip that to be the hypotenuse over the opposite, which is really just the radius over y. Secant would be the hypotenuse over the adjacent, which would be the radius over x. And then lastly, which was your question, tangent of theta would be the adjacent over the opposite, which would actually be the x over the y. Okay? And that's a lot to process. And even though we've covered this before, it makes sense that you wouldn't have it memorized because we've only done like 4 or 5 problems, example problems, right?